Hello everyone, welcome back to CLI to InfraCloud. I am MukulDK and this is the first video of our 100x Dockerfile series. In this series, we build real projects, no shortcuts, no error skipping, everything live on screen. So, let's build something real. Today, we are starting with a simple but production style Python fast API application. We will write the API, test it locally, then create a proper Docker file. Build the image, run the container, and finally connect everything using docker-compose.yaml file, including persistent storage and networking. And yes, if you break something, we will debug it together. No cuts. So, enough talk. Let's start with CLI, that is command line interface. So we are here in our CLI. I am using Zalich inside our terminal. And you can see here the 100x Docker file from scratch. This is the repository I have created for all these videos. Let's create a folder 001 fast API, or we should keep it small, fast API, and inside this folder we will create application folder, application, and in this folder we will create main.py file which we are going to edit. First we have to import operating system, then logging for log creation, then from fast API and we are also going to import request from fast API. We will create an app object from fast API. We'll give it a title, Dockerfile, or image fast API. Okay, we'll create a log directory, that is app/logs. Then we'll create okay, we have to check the directory os make directory. If it's not directory, and exist underscore okay is equal to true. So this is our object. And this is the log directory. Logging basic config. Okay. So here we are going to add the basic configuration for our logging. So we'll add the first thing, file name for our log file, log directory, application.log, then level, that is logging.info, then format. Format starts with dollar sign, and we have to add the date. So for that, ASC time, then uh, label name, and then messages. So this is how our format will be. First it will show the time, then level name, that is info, debug or error, and then the message. We are going to create now the logger equal to logging dot logger. We'll put it here. Okay. So even though this is just a logger type project, we are going to add some additional things like we are going to use it for our gateway API in Kubernetes cluster. So let's make it a more production level. First, we will define an object or info and return some environment variables. So first pod, then we also need namespace, uh, pod ID, or we'll do pod IP, then node name and host name. These are the general fields. We are going to see in our Ocean file. So get in UV. As of now, uh, let's add some real things. Okay, so pod name, namespace, pod ID, node name and host name. What we are going to do when we deploy this on Kubernetes cluster, we'll add those things, these environment variables, inside our deployment file or any other file where it is more suitable. But most probably they are inside our deployment file. Then we are going to create our fast API part now. App get request here, this, and logger info. Home URL triggered, and we'll return request first, method, request method, then URL, that is string request dot URL, client, request, client, host. If request client is available, and then header, request dot header. So this is the information we will provide in our home URL, and let's add status, success, time, that is date time, UPC now, ISO format. Okay, let's add some more URLs, and we will add health check. We use health check for checking health with the Kubernetes cluster or Dockerfile in production level. So let's write K9S, and we only give one thing here, that is status success, not even this. Then clear this thing, also the async, we don't need it here. Then let's add pod info. If we hit pod info, we will provide here and let's remove this request part. Okay, so we have 3 URLs now. One is this root URL, health check URL, pod info URL, and Do we need something else? Okay, log testing. We have to change this also. For input triggered and manual log generation. Here we will send status success time log file. For log file we have to just provide log file location, this log directory slash application dot log. Okay, so our Python application is done. Let's add requirements. Dot requirements.txt file. We are going to need FastAPI, and the other thing we are going to need is just let me check. UVCon. These are the only two files we are going to need. Okay, let's get into the folder application. The requirement should be here. Okay, we have requirement.txt and we have FastAPI and UVCon inside it, and we have main.py with this information. Okay, so let's try this application first. We are going to need Python, so let's create environment. I have Python 3 installed. We are going to use this command python 3 m -m This will create a virtual environment for our Python. Then we are going to use uv requirements.txt. You can use pipe if you want. This will install all the dependencies that are there inside our requirements.txt file. Now okay, we should have activated this first and then install the dependencies. So let's do it again. Two packages are already installed. Okay, so let's UVCon. Our folder name is application dot main. Inside that we have app object host 0.0.0.0 and port should be 8000. Okay, so we get an error at line 35 in main view. Let's check it. Line 35 go. What is the error says? Request client. Okay, so our if else is problematic here. Else none. Invalid syntax, time. Okay, we don't have. Unexpected indent, line 44. Invalid syntax, pod info, line 53. Okay. Invalid syntax, date, UTC now, ISO format, time. On line 63. 53. Okay. Make diagram. dir, we need s here. Then what is it? Permission denied app. Okay, so it says permission denied add/app because we are inside a local machine. So we need something for here. If OS, let's see what can we do for this. Path exist slash app else slash where can I put it? MukulDK, and let's put it inside documents and try this again. Documents document exists on line 8. Okay, what's the next error? Okay, we have another error right here. I have used dollar signs. Let's replace with percent sign. Okay, our application is live. Let me just change the screen. Localhost 8000. Okay, server error. Says internal server error. Health check. Health check is working. So our application is working. There must be something else that is not working. Let's try. I know this is not going to work because we don't have environment variables, but health check is working. Home is not working. So let's switch to the. Okay, we got it. Information not found. What are our other options? Pod info, log test. Let's do a log test. Full screen and log test. So our log test is also working. Okay, we can see the error here. DIST is not defined. Did you mean DICT? So there is a spelling mistake somewhere. Okay, here di ct. Let's try again. And let's run it again. It's still saying internal server error. 404 not found. Headers. Okay. So we have done header. We need headers here. Stop it and again run it. Refresh. Okay, we got our information. So this part is also running now. Let's try to get pod information if we can get anything. And it only says uh, success and time. So our pod information is also running, and this information here, right? Request. So we get request localhost from our URL, then client headers, and all the information that we have added here. So our application is running nicely. So our application is running really nicely. Let's move to the second part of the thing, this video, that is writing Dockerfile. In this folder, we have FastAPI named folder, and inside our application folder, we have main.py file. Also, there are some hidden files like .venv and this py cache. So this is for catching, and then we have a requirements.txt. We have to build a Docker file right here inside the 001 FastAPI. So let's create a Docker file here. From we are going to use Python 3.2 Slim. Every time I build a Docker file, I use apt update always. Apt install -y no install recommends. We need GCC for some Python builds. Then etc. What folder should we remove after installing something? Okay, war library, apt and lists. Everything from here. Okay. Then we'll use so before doing anything, next we have to plan what we are going to do. So we have to create user, then its directory, work directory, then permissions, then we have to create then we have to import our requirement file, then we have to run it with pipe, and also import our application. Then we have to set the user, and work directory we have already set above. So these are the things we are going to do. Let's do them one by one. User at dash m. Dash m is for creating a default user directory. We'll create user app user. Then work directory should be apps slash app. Okay. We'll also have to create another directory. Make directory p for parent. App logs. This directory we are creating because we have defined here our log directory. That should be app logs if app is present. Then we have to set the permissions. Chown should be used with R, right? App user slash app, and we are what's remaining? Okay, users expose. Yeah, we also have to expose the service, and okay, we have pretty much everything right here. We have created user, then created the directory, work directory set, permissions are done. Now it's time for requirements. Copy dot slash requirements dot txt, requirements dot txt, inside slash app. Okay, just in case. So requirements is done. Pipe install R. We have to add specifically no cache directory here because we have already seen that it creates this spy cache if we don't do this. And our requirements, then our next part is, okay, we have run this pipe command, application folder. Yeah, let's separate this thing before. Work directory app, mkdir login and user. Okay, we copied the part here. Another thing we have to copy, application folder to slash app slash application. Okay, once that is done, we have to expose port number 8000 and we have to run cmd, that is ubiquon application dot main app. Then we have to add host inside 0.0.0.0 so that it will automatically redirect it to the local host, and then we add -p for port, that is 8000. Okay. So this is pretty much our Dockerfile. Okay, we have to add some more additional things like environment, that is Python don't write et sorry by te code, and another env Python debugger. So I wrote them. I always write things like this because this is easy to read. But once it is done, we have to convert it to full caps. And yes, of course, it's a two value thing. We were getting error there. So Python don't write by te code and the Python debugger. This one is for better logging. Let's add it here. Python don't write by code and Python buffer for better login. Okay. So this is pretty much our complete Docker file. Let's build a image now. So I'm in the right folder where our Docker file is located. This is our Docker file, and we are going to use Podman throughout the whole series. We are also going to use some additional things like dive and podman-tui, which is I'm going to show you in a brief. This is the podman-tui. It gives us the information, but we are also going to use the proper podman commands right here. Okay, and we are going to use dive tool for image information taking. Okay, let's build it. Podman build -t FastAPI 001 2.1. I'm giving it version 2.1 because I have tried this thing building before. Dot. Let's see if this image is building properly. If it's not, we will get idea what's happening. Okay. Okay. So we get error here. What is the error says? Run user or add. Okay. User add. It should be user add. Let's try it building again. Okay. No cache dir. So there must be something. A new release of pipe is available. No to update pipe. Could not open requirement file. No such file or directory requirements. Okay. So this is where exactly we are going to use dive. No, we cannot use dive here as the image isn't created yet. Let's see if it's created or not. FastAPI 01. No, the image is not here. So we cannot even use dive. But we have to check what is the problem. No such file or directory requirements. Let's see. Okay, I can see it. The reason is because we didn't give the extension of the requirements, that is requirements.txt. Let's build it again. Okay, the step is passed now. Okay, our image is built successful. Now we are going to use dive, and before dive we have to check the image podman images, and we have our 2.1 image right here. So dive slash localhost fast API and image 2.1, right, extracting podman image. So this is the dive tool. It basically shows how the image built, and it's an official tool by Docker, so you can install it from the documentation. I will not show you how to install it right now, but if you need the video on it, we can definitely make it. By the way, I am operating on NixOS operating systems, so there is a substantial difference in installing softwares in NixOS versus any other operating system. So let's see the first part. This is where the image building start. This must be the environmental setup. Then we used, okay, so till this part mostly the image is installed. Then this one is 175 MB apt update, so our update went here. Also we installed GCC and removed war library. In this part we can also see what's the changes happening in which folder. This is the advantage of using this tool. We can see where exactly the changes went. Okay, in which stage. Then the next part is user add m, and you can see here the etc part is updated. Also home and app user, the user is added, the user directory is added, bash rc added, profile added. We definitely not going to need all those things in this video, but I'm just trying to show you what's the scope of this application. Then the next part, app log. So you can see here app and log, this part is also created. In the next part we have changed the permissions. The next part is requirements is added inside our app folder. Then the next part is requirements txt run, and then our main and application both files are pasted inside our application. So this is how the image is built inside the podman. Okay, and now we have to verify the image. So right here, the first number, we can see FastAPI tag 2.1 version, that is our image. We can definitely run it from here, but I'm not going to run it from here. I will show you how we are going to run it from podman CLI. So clear the terminal, podman run. I will give FastAPI name, port number 8000. The first port, that is this one, is for local machine, and this one for the container port. We can change our first port if there is something else bind to our first port. First API. Then we have multiple images, so we are going to use that number 2 version. But before that, I have to check. Okay, nothing else is there. Okay, you can see it says failed to bind port 80,000 because already in use. So let's check what is happening. Okay, our Python application is already running here, so we have to stop it before. And I think I have stopped it already. Why is it running? Okay, this is right here where it is running. Let's stop it here. By the way, I'm using NeoVim, and this is a fantastic editor. It's Vim based, and it has a lot of things. Like you can see, if I'm on main file, that is inside our application folder. Right here, you see, and I try to open a terminal, a different terminal opens. And if I went to a different folder like a Docker file, which is outside of application folder, and I open terminal, it opens a different terminal. So Let's get back to where we are. Run again this image. So it says now that the tag is already running, so we have to remove it. Podman ps dash a, and we see the fast API is already there, so let's remove it. Fast API. Every time we try to run something on Podman or Docker, any part, it's already created, and if even if it's failed, that thing will be there. So you have to remove it before proceeding with the same command. So let's run it again. Okay, what it says: error, executable file uvcon not uv. Okay, so we have misspelled here uvicon, uvicon. It should be uvicon. So okay, in that case, like if we missed something right here in the Docker file, we have to rebuild the whole file, and we have to delete all the container and images. So let's do this. So first, ps minus a, we see fast tag is here, so fast API is here. So remove it. Podman rm fast API, podman images, and we see image number version 2.1. So let's remove it also. Podman rmi for removing image, localhost and we have fast API. Okay, version 2.1. The image is removed. Podman images, you can see the image is not there now. So we have done this thing, and let's build the image again. Podman build t fast API, this time 2.2 version. Okay, it will take some time for building. Okay, so image is ready. I'm not going to show you the dive tool again. Let's just proceed with the next part. Podman run, name fast API, port number are 8000, fast API version 2.2 now. Okay, error. Uvicon help for help. What it says is no such option as P inside Uvicon. Okay. Okay. We have to build the image again because we have used P. It should be port, not P. Let's try this before building an actual image. If we got an error inside our CMD part, we can replace it. That there is a difference between run and CMD part. We cannot change run part, but we can change CMD part. I will show you exactly how it's done. So our command is uvicon application dot main app part host 0.0.0.0 and port 8000. Okay, let's try this. Okay, the image is running already. So before running this command, let's remove the image. Podman rm fast API and run this thing again. Okay, so the image is started running. Let's try check it inside our podman-tui. So we are in volumes, we are in containers now. This is the image, localhost fast API 2.2. This is running, created about 17 seconds ago, and status is up. Name fast API, ports are 0.0.0.0, that is our local host, and 8000 is the port of our machine, which is tied up to 8000 port on our container. Let's again try to access this thing now. Okay, you can see just this thing just changed, uh, and the application is live. Let's try something different now. Pod info. So we are not getting pod info again because we are not inside a cluster, but we can definitely check health and this part request. So here we are already. uh, let's check what are the remaining things. Health check log test. Okay, let's do a log test. And the log test is showing up success. App log application log. Okay, so you can see here that app log application dot log, this is the log file location, and I have set the first part here, home mukul documents, which means this is the part running inside our container and not inside our local machine, because we have app directory here. So our log directory is app log and not home mukul documents. This proves that the application is running inside our container. Let's try to access the container also. This is the podman-tui. This is a really fantastic tool with I think M, right? Yeah. With this key M, let me show you the help first. This is the help part. M displays the command menu. So we will go inside our running pods and M to check options here, like attach, checkpoint, commit, create, difference, exec. So with this we can also execute command, and we have all the required option that we usually use here. Attached to a running container, I haven't tried this one. Okay, so somehow this is isn't running in my part. Okay, so our pod is running right here. Mm, let's try to access this with podman exec it or fast api sh. Yes, we are inside the pod now. Who am I? So it says root. Okay, this is a bad practice because we are a root user here, and we also run the command via a uicon, that is our custom command that we used here. So we are definitely going to rebuild this part. That's why we are also going to set user here, and that should be our app app user. Okay, then let's check users. Okay, it isn't showing users, maybe because this is a Python image. So ls is here. We will print working directory. We are inside app directory, which we defined here, right? Our work directory is app. Okay, so ls and our application logs and requirements are here. So let's get into logs folder and check application log is here. Cat. Okay, cat application log, and we can see that home url triggered, pod info triggered, and all these logs are here inside our application log file. Application, and we have our main.py file also here. Okay, so this confirms that everything we have built till now is running nicely. Okay, before building the next part, I just forget to create this part. Just a second. We rewrote the Docker file recently that we used. We added user and the this port part that we had a problem with. So let's rebuild it before moving ahead. Let's remove the fast API image first, or container first. Then we are going to use remove the image podman RMAP for image, and our image tag is 2.2 now. Okay, the image is removed. Let's rebuild the image now. Podman build dash t. We are going to use 2.3 version now. Okay, so image is created. Let's try to run it. Podman run fast API dash p for port for that is 8000 to 8000. Fast API image 2.3 now, and it looks like everything is working. Yeah. So the image is now completely success. Everything worked with a single command. Let's move to the next part, that is building docker-compose.yaml. Okay, so the next part is building docker-compose YAML file. Let's get back to the where we left recently. What is the use of Docker Compose file? Docker Compose is the file which we can use for multiple things like defining networks, volumes. But the most important role of Docker Compose file is that we can run multiple images with the single Docker file, and all the networking and everything will be handled by Docker Compose file. Of course, we are going to use podman-compose for this, but we don't need to name it podman-compose. We will just name it docker-compose and everything will work. Let's create the file. Docker-compose.yaml file. So the first thing we have to give is version, but I don't think we should use version, because if we don't use version, it will automatically select the latest version. Then we have to use services. For services, we are going to use fast API and name or container name. Container name should be fast API. Uh, image name should be localhost fast API. Let's check the name before. Podman images, and this is the name of image that we are going to use. Fast API. So let's copy it and paste it right here. Okay, so done. Next thing we need is port. So port should be in the list. So 8000 to 8000. Okay, then we need volumes, and for volumes we are going to use something like logs. Okay, we have to create volume for that, volumes, and we will create logs here, and that's what we are going to use here. For this we are going to set our log directory. We need a persistent volume, which means even if our container is lost or dead or anything happened to the container, or we have to change the complete container, the data that we stored in the container, that are the logs, should be there, and we should be able to retrieve it from some place. That's where the persistent volume comes up inside Docker. If we create a volumes, that is anything we can call it, and just give it here, it the Docker or podman will automatically handles everything else. We don't need to set up any directory or any location or any other place to save these logs. We just need to create a log, create a volume. We are going to use app slash logs slash everything here, and okay, or we can just give it apps log. Then we need a networks. Inside network we are going to use fast API network, and for this we have to create network, fast API network, and we have to set driver to bridge. That's everything a file should contain. One more thing, this image part here, this is localhost and fast API image version 2.3. If this image is not here and we don't write this localhost part, it will try to find the image on our Docker Hub repository. So let's, just in case, create a Docker Hub repository for this. Let me move to the footprint part. Okay. Docker Hub. So here you can see that I already have a fast API image, but this must be an older one. Let's check it out. You can see it's version 1.5. So what we have to do is we have to update this image. Let's see how we should update this image. Get back to the coding part. Here in this repository, let me explain you what are the things here. This is the repository name, that is 100 Docker files from scratch. We have target directory. Inside the target directory we have some things like 11s, where I have explained what exactly we are going to do with all these things, and what is the use of this repository or this videos or this series, like how exactly this thing is useful to us. Second thing is I added documentation for updating the Docker Hub. Here I have given information like podman tag, fast API image, and then how we are going to use it. So this is the part where we are going to use it. Ignore the errors, please. Podman images. You can see we have multiple images for fast API, that is 1.7, 1.6, that which are not useful now because we have created the latest image. Somehow, yeah. So it will be better if we remove those images. Let's remove them. Podman RMI for removing images, localhost, fast API version 1.6 first. Okay, and now version 1.7. Both will be deleted now. Podman images, and you see we only have the Podman localhost FastAPI version 2.3 image, which is the latest one we built from this Docker file. Okay, so let's follow this thing. Podman tag FastAPI. This is the version number. Okay, we are going to give, and the Docker Hub repository name, that is MukulDK here, and then FastAPI. The version number we have to give to the repository. So let's do this. Podman tag FastAPI 001 2.3, then docker.io for Docker Hub repository. Username is MukulDK, and the name we are giving this image on our repository is FastAPI dash 001 version number 2.3. Okay, and the next command should be podman push docker and the image name. Okay, so let's do this. Push.io MukulDK FastAPI version 2.3 auto completed, getting image source signatures, and within some time this image will be updated. Okay, you can see the image looks really heavy. This might be because we kept the Python part, that is cache or something there. We will definitely try to remove this on our next video series, but as of now we are going to upload this. I might fast forward the video here. To use the Docker Compose file. Okay, we have Docker Compose file and Dockerfile also, but before we run our Docker Compose file, we must check something, that is podman ps-a to check if the same name which is given inside our Docker Compose file, that is FastAPI, is taken by some other images. Okay, so there isn't anything. So let's just do podman compose up dash up. Okay, unused network FastAPI network warning podman compose. Let's try. We already have localhost here. Okay, something is not working. Dot unused network FastAPI network. Okay, the name is the same. Okay, FastAPI network. Let's try to figure it. We are inside our podman-tui. This is where we are going to use this podman-tui thing. Let's check if we have our app, 3-tier app networks. We don't get the network created, which means our podman compose isn't created. Another thing we can see, there isn't a single connector container here, so the podman compose file didn't work, which means we must have some error inside the podman compose file. Let's try to check it. Volumes, networks, and what it says: warning podman compose, warning unused networks FastAPI network. So we definitely added networks here. Maybe it's network then. No. Fast API network, and we also gave driver to this part. Okay, I can think of one this thing, and there should be ports. Let's try again. Networks. Let's try this. We are going to use ChatGPT here. Let's try what is the part. Okay, I used ChatGPT for learning some errors. What it says, podman-compose up dot at the end. Compose up dy this warning, unused network, FastAPI network. You define a network YAML, but no service is using it. You pass dot service podman compose. If you want paste, no, we are not going to paste it. Of course, we realize that something is not working here. FastAPI network. Let's change it to something else. Network 1, and just call it network 1 instead. And podman compose up unused networks network 1. Let's put it somewhere above and try to run it again. Network 1 again, same problem. Unused network 1. Let's try to figure out your podman-compose YAML is fine. Service, you wrote service, and okay. So sometimes we need, we definitely need ChatGPT, because I wrote the name of services wrong. Let's try this again. And FastAPI application unicorn running. Let's try this now. Okay, it's running. Log test is running, and let's try this. This is also running, and let's try pod info. Of course, this will not run, but we can make it run if we add some things right here inside our Dockerfile. But let's just not add them. So in this part, we are going to add this pod info part, which was which we haven't used because this line here was commented. I just removed it from comment, but as you already know that if we change anything in our main application, we have to rebuild the whole thing. So first of all, podman compose down, podman ps -a, so nothing is running. Podman images, we have the image FastAPI RMI, and okay, we removed the image. Now the next thing is uncommented this part. I also realized that here it should be OS, not OG. So let's repair that thing, and with this build the new image. Podman build T FastAPI. This time we will give it 2.5 and the building is start. Okay, the image is built. We have fast API version 2.5. Then we have to use the Docker Compose, but here we have to define the newer image, that is 2.5, and let's podman compose up. Okay, the podman compose is running. We had internal server error at pod info before. Let's just try this part. Okay, so this is working. Our get method, which was already working, again working, which means our pod is up now. Let's try pod info now. Okay, so here we can see pod info. We have pod info null, namespace null, pod id null, node name null, because these are all those things which should be there inside our Kubernetes cluster, which we are not running right now. We are running podman compose, but we did get host name, which is this one, because host name is the part that is inside our operating system itself. This host name is our operating system itself. You have its host name, but it doesn't have node name, pod id, namespace, pod name, which we try to define here, like inside our docker compose, but I guess this thing didn't work, so never mind. Okay, with that we have already completed this project. So till now, we write the Dockerfile, the FastAPI application in Python, and the Docker Composer file also. I have also shown you everything is working, like pod information, health check, home folder, and the manual log triggering. What remain is now persistent volume, which I haven't shown you, but it's also working as we have already taken care of it. So let me show you how it works. Okay. So I think you can see my screen. The application is not working, and we have here. So let's just start this podman compose up. The application is running, and we access the home page right now. This is the home page, pod info page. Then we will access health check page. Okay, and the last is log test page. Okay, everything is working except the podman part, podman info part, because we are not running a Kubernetes cluster. So let's just get to this part. Here you can see these are the logs of this application. We can also run this with podman compose up dash d in a detached mode, so the terminal will be clear and these things will not shown. So let's just access the podman exec dash it interactive terminal, fast API, which is the name of our app, and sh for shell. We are inside our pod. Last time we also added user, so let's check the user. Who am I? And we are app user as we define inside our Docker file. Now let's just check the logs. Cd logs and cat application.log. So you can see these are the things. We recently visited pod information, manual, pod, home. Here you cannot see that we have visited the health check page, because in our health check page we didn't wrote this code, the logger information part, because we don't need it inside health check part. All the use of health check part is just for Kubernetes or Docker health check usage. So we are not going to add this line here, and that's make this thing. Okay, so let's move to the next part. The first thing we are going to do is exit the container. Then we are going to stop the podman compose. With podman compose, down. Okay, Ju- just for the confirmation, podman ps a, nothing is running here, nothing is running. And what generally happens, if we create a pod, and it creates something data, then we destroyed the pod, the data along with it got destroyed. But as we have added persistent storage inside our docker compose file, which is right here, volume logs, and this part here, volume log app logs. So this app log parts inside our container is bind with logs part, which is handled by our podman volumes. Let me show you where the volumes are. This is the container page, pod page, system connection page, secret page, network, images, and this is the volume part. You see here the 001 FastAPI logs named volume is created. And let's check what actions we have. Create inspect, so we can inspect it. Inside inspect, we can see that 001 FastAPI logs driver local. And what we can see more here is that's all the things, UID, GID, and that's pretty much every information. Okay, so let's just run again this part, podman compose up. Okay, this is up. We haven't refreshed this page, so it must not create any log. Still, we are going to check the logs right now. Podman exec it sh, and in ls inside logs cd, inside logs we have application log cat application.log, and you can see that all those logs which are previously created are here. Just for the time, I can also verify it with the time. Right now it's 8:06 p.m. and you can see the time right here somewhere. Okay. Okay, so inside the container we have different time. So right now it's 14:36:36, and the logs are for from a long time. That is from 14:06, which must be the first time when we run podman compose up podman compose up command, and since that time the logs are here. Okay, let's just exit this thing and also podman compose down. So this is pretty much inside this video. I have shown you everything. The FastAPI application, then requirement file, local testing, Docker file creation, Docker image creation, Docker container running, then Docker compose file running, volumes and network configuration, also running compose file, test all endpoints, then check in volumes, and debug. We already debug almost every issues. And cleanup and file structure. Okay, so thanks for watching this video, and see you in the next one.